Welcome back, everyone, to EDS 301. And tonight's topic is going to be over social cognitive theory and its uses in the classroom. But first, I want to kind of recap a couple of things we talked about in the previous unit, which focused on kind of a behavioral approach to learning. If you'll remember from the previous videos, the focus with a behavioral approach is through the use of reinforcement or punishment to shape or change behavior, and that the way that we're going to understand whether learning's taken place is that we've seen a change in a student's behavior. Now, principally, we don't focus on much of our instruction on like how do I use behaviorism or behavioral theory to help students learn. Well, we don't look at it from a theoretical. We look at it from more of a classroom management standpoint, maybe from a lesson planning standpoint, which focuses on that. I believe learning's taken place when I've seen a change in behavior. How do I get those changes in behavior? Well, most commonly we use reinforcement, and so this works across K through 12 into college, the whole nine yards. Sometimes you look at some of the examples, and they might be a little bit elementary in scope. But the truth is, we do a lot of it in the high school setting as well. We want students to be more responsive. We want them to participate. One of the things that I'll see in college classrooms too is that you ask a question as a teacher. Granted, you want lots of engagement in the discussion in the classroom, and then students say things like, "I don't know." Well, teachers get nervous. They get nervous, and they get that's awkward silence, and then they say something like, "Oh, okay," and then they just answer it themselves. Well, after a while, all the students get it, don't respond, and the teachers will answer the question themselves. What am I doing is I'm reinforcing that I don't know response. Okay, I don't want to reinforce that, so I take time, give them a hint, but I want them to engage. I want them to respond, and so the idea is that we shape behavior, we change behavior by encouraging students, reinforcing them. Sometimes we look at it from a classroom management standpoint. We see bad behaviors that the students are engaging in. So we want to make sure that we're consistent there, and that if we need to punish a student for the behavior in the classroom, that we're trying to decrease the behavior. The idea is that we do a lot of reinforcing, a lot of shaping of behaviors in classrooms of all ages. But the idea is that we're looking for changes that are actually observable, that are measurable, right? That's the idea of the learning objective and the learning outcomes. All right. So we focused on from a behavioral approach. Now tonight's conversation, I say tonight because I'm doing this at nighttime, but today's lesson is going to focus on social cognitive theory, which you'll see is really a hybrid between kind of the behaviorist principles and some of the more information processing principles, or the idea of internalizing stuff. Behaviorism focuses more on the environment and external events. Information processing theory focuses more on how we internalize things. Social cognitive theory, which is the use of models or observational learning, is kind of going to be a bridge between both theories. And this is Bandura's work, etc. So what I'd like to do first, and everybody's got the PowerPoint I sent to them, and what I'd like you to do is, before you go further into the series of videos, make sure that you go through the PowerPoint, and I ask questions along the way that I want you to pause and reflect on for a minute, even if it's for a minute or two, just so that you're actually internalizing the questions and thinking about them and perhaps coming up with your own responses. You know me, I've got plenty of stories, so I will tell you, I'll give you examples from my experience as a teacher or from as a parent or whatever the case might be. But the idea is that the PowerPoint that I send you is not just something that you just kind of shuffle through real quick and say, oh yeah, I'll look at that time before the test. I want you to kind of look at the material in context to the video as well. Maybe it's something you could have if you have it on a computer, you have the PowerPoint up, and maybe on your phone, you pull up YouTube and you have the video going, so you guys can have both of them going at the same time. Okay? So anyway, or have a split screen or however you might do it on your computer. So this is good. This material tonight is going to focus primarily on Module 9. Okay? So you'll notice that in the PowerPoint, I start off with a problem to solve. And the problem reads that a skier wishes to build a rope tow to pull herself up a ski hill that is inclined at 15 degrees with the horizontal. Calculate the tension, T, needed in the rope to pull the skier's 54-kilogram body, including the skis on which she stands, a 1.2 meters per second acceleration, and just ignore friction. Now, take a minute and give it a try. Where would you start? What would you do? You're up at the board. I call you to the board and I ask you to do this. Now, my experience has been that when I ask students to come up and do physics problems, math problems, things like that, there's a little bit of hesitance. So what do? I don't tell them the problem to begin with. I just say, someone give me a hand. Come on up to the board. And when they get up to the board, then I unveil the problem, the physics problem right here. Now, granted, how would you feel if that was asked of you and you're standing at the board? This is what I get a lot of times, okay? So what I get a lot of times is students will draw the problem out. Good strategy, like the strategy. Let's draw it out. We've got a person that's going to go up a hill, 15 degrees. You can barely see it there, but I got 15 degrees. And then you kind of write down what you know. What do you know? Well, I'm looking for T, what the tension is. I know that the mass, or the person's body weight, is 54 kilograms, including the skis. And I want to get at an acceleration of 1.2 meters per second and just ignore K, or ignore friction altogether. Oh my goodness. Pose that question to your students. Watch what happens. Well, if you're teaching elementary, it wouldn't be appropriate. But you might get a lot of people that are stumped. That's okay. That was my intention. Okay, I wanted to stump the students. And what you see is when you take a look at the next slide, you'll see that T equals mass times acceleration plus mass times gravity to the cosine of 75, because it's 15 degrees with the horizontal. You do the math, 54 times 1.2 meters per second plus 54 times 9.8 meters, which is gravitational. And the 0.26 is the cosine of 75 degrees, gives you 200 newtons, okay? What the heck? What are we talking about, right? Any student sitting up at the board that's confronted with that problem, what's going through their mind? What are they thinking? Imagine you're at that board. What would you be thinking as I'm asking you to solve the problem? A lot of times students are stumped, frustrated, thinking, oh my God, let me sit down, please. Anybody know how to do math? Anybody know physics? Somebody else give me a hand. We're looking for a lifeline, right? Looking to call somebody. That's totally expected. Okay, that was my intention. I wanted to get that awkward feeling when students get up and then they have to do this, right? So I show them the problem, they look at the answer, they look at the solution, and I say, whatever, Eric, I'm not in a physics class. So then I ask, can somebody else give me a hand at the board? Now, what do you think students are thinking then? Give me a hand. Somebody give me a hand at the board. Most people are looking at me like, are you crazy? I'm not coming up there. I'm not doing that. And then I give them a problem, and the problem reads, smart, smarter, and sometimes as the student's coming up to the board, I say, oh, you don't even need to come up. Just tell me what it is. And they look at it and go, smartest. I'm like, oh, thank you. That's great. And then everybody looks and laughs. And they laugh because they're like, man, that's not what I expected. I was expecting a physics problem, a math problem. I said, I didn't say what the problem was. I just said, someone give me a hand with another problem. What have I done? I've created expectations, right? I've created expectations. And the idea is you notice, what does it feel like to stand up there at the board, asked to do a problem, and you are not prepared to work out one of those problems. On the flip side of that is I ask students to come up and do a problem that's relatively simple, okay? I could have done any kind of problem. I could have put a box, a square, and have one side be 4 centimeters, and it's a square. They look at the box and they're like, oh, 4 times 4 is 16 centimeters. So ask for the perimeter. They got it, no problem, right? But the idea is I'm trying to get that feeling Now that's the premise when we start thinking about it is our topic for tonight is social cognitive theory. What do we know about social cognitive theory? Okay, remember theories are used to explain why. Why does the student behave the way they do? Why is the student responding this way? Why? Right? Okay. And social cognitive theory explains or helps us understand why people behave the way they do from observation or imitation of a model leading to a learned behavior. All right. Now, the typical, and you look at the book and they talk about Bandura's and the Bobo doll experiment, right? And what do we know from the Bobo doll experiment? Well, what we know is that when a kid, and I usually I put it in kind of contemporary times. You can take a look at a student or young kid is watching an adult with this doll, one of those dolls that you punch it and it bounces back up and stuff like that. If a kid is sitting there watching an adult go karate chopping on the doll and it bounces back up, and they leave the room and they leave that student sitting there by themselves to their own devices, watch what they do in in that room. They start chopping and hitting at the Bobo doll itself. Now, if in another part of the room, an adult is sitting there doing a puzzle or doing something at a table or anything like that, you'll find that the students oftentimes imitate the adult and leave the Bobo doll to itself. Okay, the idea is what we've learned is that given a presence, a teacher, an authority figure. I use the example in class oftentimes is they'll say um, kids are sitting there watching a movie and they're watching, let's say, Teenage Mutant Ninja Turtles, okay? And they just get done watching this teenage, Donatello, Michael. They got all the characters. They're ready to go. They come into a classroom. It's got different activities in the room, and there's this doll that you punch and it bounces back up. They just got done watching Teenage Mutant Ninja Turtles. Man, they go off on that thing, kicking it, punching it, all that stuff. And why? They just saw these characters in this movie doing it, having fun. It looks cool, and that's what they do. Now, if the kids were watching something like Dora the Explorer, and they come into the room, you might find a very different experience. They start doing puzzles, or they're doing swipe or no swiping, whatever it might be, but they're less inclined to go punching the doll because Dora's not a very violent character in her show, right? So we're going to focus on how do our kids in the classroom learn through us as models, and what do we do in the classroom to help reinforce positive behaviors and keep them both motivated and moving in a positive learning direction, right? So, having said that, we're going to turn our attention to the basic assumptions behind social cognitive theory. And I'll actually go over each one of them independently here in a second. But at first, it starts with that people learn through observation. Okay? People learn through observation. Now, in behaviorist ideas, when we thought about it, what happened? The student does something, teacher reinforces that, the student's likely to do it again. The student does something in the classroom, the teacher doesn't like that and either ignores the behavior so that it'll go away, or maybe they punish the behavior so it'll decrease. But the idea is the things that students get reinforced for, they're more likely to do it. Things that they're punished for, they're less likely to do it. Now, with social cognitive theory, we're going to talk about how it is that students learn through observation. We're going to talk about how we need to separate learning from behavior. We're also going to talk about how behavior is goal directed, okay, and what we can do as teachers to help with that goal direction. And then lastly, how the changes that we see in our students always aren't from direct reinforcement or direct punishment. So let's talk about each one of those independently.